My name's Craig Latta. I'm a computer science researcher from Berkeley, California. And for the last few years, I've been playing around with Smalltalk and JavaScript and the web platform. And I'd like to show you what's going on in a project of mine called Caffeine. Now, first I'm going to try to share my screen. Do you see something 3D-ish?
I see it, yeah.
Yeah, okay. So what we're looking at is an integration of Squeak Smalltalk running on the Squeak.js virtual machine by Vanessa Freudenberg and A-Frame, which is a WebXR. XR is VR, virtual reality, plus AR, augmented reality. A-Frame is a WebXR framework for web browsers. So this is a web page that you're looking at running in Google Chrome. And this integration of Caffeine and A-Frame is a web app that I'm calling Worldly, sort of following on name-wise from the Lively project, which was a JavaScript IDE in which the Squeak.js VM was first developed. And so over here, the frame rate won't be great, unfortunately, because my GPU is doing both this web page and all the stuff that Zoom wants it to do. So please bear with me. So over here on this plane in A-Frame, I'm screencasting another tab from this same web browser that is looking at a Google Docs document from my talk notes. And I'll be talking about that more later when I get into more of the details of Worldly. But first, I'd like to talk about the origins of Caffeine a little bit. So if you go to squeak.js.org, you'll see Vanessa's site for Squeak.js, which is a pure JavaScript implementation of the Squeak virtual machine. So if you're, or I should say the Open Smalltalk virtual machine, which runs not only Squeak object memory snapshots, but also Cruise and Pharaoh and Newspeak. And if you're familiar with that virtual machine, you know that a large part of it is actually written in Smalltalk and then translated to another language where it can be compiled, taking advantage of the native machine instruction generating capability of whatever backend compiler you want to use. And originally, that VM using this translation framework called Slang generated C code, which could be compiled to a native app for a bunch of platforms. So Squeak started out using Slang to generate C code, which was compiled on Mac OS and Windows and Linux to make native apps on those platforms. But the way Slang was written, it's quite easy to make translators for other languages besides C. So in 2015, Vanessa Freudenberg wrote JavaScript support for that. and generated the Squeak VM that way, and using the Lively JavaScript IDE, got that to run as a Lively app. And when it was all working, including support for a simple file system using the IndexedDB capability of the web platform, it became a standalone thing. It no longer had to run as a Lively app, but it could just be something that you loaded into a web page like any other script. So as easily as you could load, say, jQuery framework or React, you could load the Squeak.js VM. And included in that initial release was a two-way bridge between Smalltalk and JavaScript. So from a Smalltalk system, you could make calls to JavaScript objects, including passing block closures as JavaScript functions to use as callbacks, for example. You could also use promises. So you could do all the, latter day async await stuff from JavaScript, and also create ES6 classes in JavaScript. Basically, you could do anything that any other JavaScript framework might want to do, except you could do it in a live coding style. Now, I thought this opened up a huge opportunity because Smalltalk and JavaScript actually have a great affinity for one another, I think, because they both lend themselves very well to live coding. Even though JavaScript isn't used that way by most people so much, because of all these additional build steps that tend to get added to the JavaScript workflow. When you're actually running a JavaScript app, say a web page, you have a live system there. You can alter all of the code, layout, and graphics assets in your web app, on the fly. So if you've got this bridge for doing that stuff from Smalltalk, then there's just all sorts of things you can do. So I wanted to try and see, what interesting mashups I could make between a Smalltalk running on the Squeak.js VM in a web page and the web page environment that surrounds it. So I created class hierarchies in Smalltalk that mirrored and proxied JavaScript behavior, and started doing mashups with every interesting JavaScript framework I could find on every device where JavaScript runs. And nowadays that's a huge number of devices because web browsers basically run everywhere. The first app I did was one called Snow Globe, which just showed screen sharing from a remote Smalltalk to Squeak.js in a web browser, just in 2D as a single page application. And once I had that working, then I thought, Caffeine was interesting enough to show, and I started presenting it. I first presented Caffeine at ESUG 2018. Let's see here. I can scroll here. Yeah, so after I had that done, I thought, well, to really be able to do anything that any web app I've ever seen can do, I need to be able to do what the Chrome DevTools can do. The Chrome DevTools is just another JavaScript application, it turns out, using APIs which are available to you if you're running from a Chrome extension. So I wrote a Chrome extension that could speak to Squeak.js, thereby giving the Smalltalk system being run by Squeak.js the power to use all of those APIs. And once I did that, I also gave a DevTools panel interface to Caffeine. And the first thing I decided to start writing was a GUI for the Chrome DevTools. And I'll just open the Chrome DevTools in this browser here. The Chrome DevTools are really cool, but the user experience is kind of limited if you're used to, a full-on graphical environment like we are from. Oops, some keys got through. I didn't mean to. If you're used to a full-on GUI experience from Smalltalk, so now that I have access to all the APIs that the DevTools themselves are using, I can make a GUI that runs in Squeak.js that has access to all of the objects that are being used by the DevTools. So I could write a GUI for the Chrome DevTools debugger, for example. So instead of being limited to a UI like this, it should be possible to actually have inspectors and browsers that we're used to, and even maybe extending the traditional Smalltalk debugger UI to deal with web browser JavaScript. And so here is another instance of the Squeak.js VM running in a Chrome DevTools panel. So from here, you can get your hands on all of the JavaScript objects that every other panel and every other tab and every other window in this web browser can see. So just as a very simple example, I'll show that the JS bridge that Squeak.js gives you creates a global object called JS, which basically represents the window, the web browser window you're running in. And you can send it messages that this window would understand. So like if you were just in the console here, you could say something like window alert. Hey there. And you get this little dialog box here. So you can do the same thing from Caffeine. Now, once I had that stuff going, then I had access to absolutely every JavaScript API that any other web app would be able to use. And that put me in a position to implement this immersive worldly app that I'm showing now. In particular, I'm using some of the Chrome DevTools APIs to screencast another tab in this web browser onto this 3D A-frame plane here in this world. And I'm using this, sorry, can you see my mouse pointer as I move it around?
Yes.
Yeah, and I'm using this squeak system running in another A-frame plane to do a lot of the event handling that I need to make this stuff work. So it's one thing to screencast a tab onto a plane here and have it update. But it's quite another to actually handle mouse events that are detected as intersections on this plane from A-frame's raycaster and turn them into 2D events that actually make sense for the canvas running in this plane. So all of that logic for doing projections of 3D mouse intersections into 2D mouse events, I wrote that all in Squeak. And yeah, so here's one plane, and then here's another plane, which is just showing the traditional morphic user interface from Squeak. Yeah, and the frame rate, it's not great. Normally the frame rate is about 60. So the main idea about Worldly is I'm doing some, spatial computing interfaces, immersive interfaces, and I would like to be able to live code them for one thing, and I'd like to be able to live code them from within the world that I'm making, especially when I'm experiencing the world using a 3D headset like the Oculus Quest. It's kind of a pain to have to take the headset on and off whenever you want to make a change to something. It's sort of a modern day version of the compile, build, run cycle that we have been trying to get away from with live coding all this time. It's even worse when you actually have a physical thing that has to go on and off your head. So with Worldly, I've built this live coded in-world way of writing code for this space, for this environment. And that's sort of an interesting question. What could a spatial IDE look like? It's great to have the traditional 2D morphic interface, running in a plane here. But, even then, there's in this 3D world, say you're building something that, actually exists off here in the distance. You don't want to have to keep coming back to this spot in the world to make changes to your code either. You like things to be able to follow you around. I did some initial experiments with making sort of heads-up displays, 2D things that kind of stuck to the glass of your view as you moved around in the world. But I think there's a lot of potential for making tools that actually exist as 3D objects in the world in their own right. So I've got some initial experiments here. This is something that I'm calling the Worldly Cube. And it is a 3D cube that has multiple morphs mapped onto it. And floating around it are these 4 other cubes of different colors that have different functions. This red one you can use to move the cube around in space. And normally it just moves around here in the XZ plane, but if you hold the shift key down, then you can also make it move around on the y-axis. And each face of this cube, is just a tool that you're used to using, that you can type into. And usually I find these tools sort of roam in packs. Like if you have an inspector open on some object, like right now I'm just inspecting number 3, usually you'll have a class browser open to the class of that thing nearby. And you'll often have a workspace open as well. So this cube is sort of is a nice way of just grouping these things together. And you can also stack them. So you could have a ton of these things open at once in this 3D world, in sort of a way that's perhaps even more space efficient or virtual space efficient than just having a bunch of large planes open that have big 2D screens projected onto them. Yeah, so that's one experiment of what's going on here. And so I'm also experimenting with getting all of this stuff to work on every device where JavaScript runs. And so right now that includes the Oculus Quest VR headset, the iPhone and iPad, as well as other environments that aren't web browsers at all, like Node.js for server-side stuff. Now, my current experiments include a project called beat shifting, which is playing music in sync but out of phase, using the Croquet JavaScript object replication service, and also an alternate Netflix player for doing crowdsourced narrative editing. And you can read more about those at my blog, which is thiscontext.com. But in each case, these are sort of novel mashups of a Smalltalk system running on the Squeak.js VM, which is embedded into some environment, either a web browser on some device or Node.js. And yeah, so that's sort of an overview of the whole thing. And yeah, now I'd like to take any questions that people have about it.
Thank you, Craig. There's a question from Andy in the chat. Andy, do you want to repeat it or shall I?
Yes, by all means. So I've been playing with Squeak.js recently on my iPad Pro, and now I've got the mouse and sort of integrated into the keyboard. It's tremendous. But what I was wondering was, is it possible to compile to WASM? And if it did, would it make a difference? Or is the dynamic nature of Squeak such that we wouldn't really get much of a boost from it? I was just curious.
At the moment, WASM is a little bit slower than the best JavaScript runtimes. So it wouldn't make a difference yet. And also bringing up a fully functional system is a lot more work than it will be once the WASM garbage collector spec is fully implemented. Squeak.js actually represents most of its objects as JavaScript objects directly, and is able to take advantage of the JavaScript runtime's garbage collection to a great degree. And I think, and similar leverage will be brought to bear with WASM. So it's sort of more work than it's going to be if one just waits a bit for WASM garbage collection to come online. I think. I've done some initial experiments with the stack version of the Open Smalltalk VM on WASM, and yeah, it's just not as fast. So I think eventually it will be an interesting alternative, but right now it's not worth the effort.
Thanks.
Maybe I can say a thing. Hi.
Yeah, hi Vanessa.
Yeah, so for Squeak.js, it doesn't really make sense to compile to WASM, in my opinion. There will be a new JIT compiler that will be a lot faster than the current one. So I think that's the way to go for Squeak.js, but WASM could be used for to speed up some operations. Like I kind of guess BitBlit would make a difference if we actually compiled that to WASM, but not the whole VM. That wouldn't make sense.
Yeah, and that's similar to how now already I'm using web workers to offload compute-intensive things. It's sort of like being able to run things in their own JavaScript runtime thread. I use that actually in the first app I did, Snow Globe, for doing most of the rendering of the remote Smalltalk onto the local HTML5 canvas. And that gave me a huge speed up. But again, I'm still just using the native code generation that the JavaScript runtime gives me. It's just not running in the main thread with the rest of the Smalltalk virtual machine.
Yeah, I have a question. Do you have access to the microphone and the camera? That could be interesting in education.
Oh, yeah. You have access to all the devices that any other web app would have. So you can use the microphone and camera and Bluetooth and NFC and all of those devices, even the file system to a limited degree.
Can I follow up on this idea of connecting with things? There was a discussion that I was having with Vanessa over in the Croquet Discord, and I think what you're showing is a more generalized version of how might we create synchronized virtual spaces, maybe using Croquet, maybe using some other thing, but fundamentally, is it that we need to move our models into the JavaScript space and then have announcer frameworks to be able to talk back into Squeak.js? I wasn't entirely clear about that.
I don't think so. I think that's an option, but I think it's also an option to keep your models in Smalltalk, since you have access to any JS API that you want. The crucial thing is just being able to successfully send as JS argument to any given Smalltalk object that's going to be involved in these API calls, so that the Squeak.js JavaScript bridge can actually use it in JavaScript land.
So if we wanted to do co-browsing somehow or co-exploring in your space, we would be emitting through the JavaScript bridge, I don't know, say your location or your model values, and I would be consuming them and vice versa.
Yeah, and I would probably use Croquet for that. Although there is some support in A-Frame for doing multi-user things over the network also. It's just called network A-frame. It's just a loadable thing for A-frame. But I would rather have something that's sort of as framework independent as possible. And Croquet, I think, is a great choice because it runs at a frame rate which is, plenty fast enough for anything involving an animation loop.
Thanks.
Any other questions?
Yeah, maybe it could be interesting. Are you able to get a browser in a Squeak pane? I mean, if in your world you can see a pane with inside another tab, can you have a pane with a page, with a web page that we can manipulate from wherever?
Yeah, exactly. I'm working on documentation for Caffeine, and I've integrated that with a 2D single page application that I did with Caffeine, which embeds an iframe showing a wiki where the documentation actually lives into a 2D morphic window. And that 2D morphic window can either be inside another iframe that has the entire morphic UI in it, or just in its own free-floating HTML5 canvas on the page. Yeah. I'm actively involved in an experiment.
That's very good, because we don't have a good browser inside Squeak, let's say. So
Yeah. By implementing Squeak inside a browser to begin with, then yeah, you automatically get all of these capabilities. Yeah, at this point, I've tried pretty much every combination of UI machinery. I started off, just with the Squeak morphic UI taking over the entire web page, and then running it in an iframe in a larger single page application, and then running individual morphs on their own canvases in a larger single page application. Then projected onto a 2D plane inside a VR world. Then individual morphs in their own canvases on top of this VR world, and then now mapped onto multiple morphs mapped onto the faces of a cube. Yeah. So yeah, a bunch of combinations are possible, and you can do them all at the same time.
So the JavaScript bridge, can you bridge sockets through WebSockets so you can get, like, for instance, two different Caffeine instances having some kind of byte stream back and forth with each other?
Yeah, exactly. And another experiment you can read about on my blog, thiscontext.com, is an implementation of a module system called Naiad, which is for team development. And yeah, it's constantly exchanging tons of data about what people are working on, and history information about what has changed recently. Yeah, and that uses WebSockets heavily, and of course WebSockets are already built into the web browser you're running, so that's using them is straightforward.
But on the Caffeine Smalltalk side, they can present as just ordinary streams, external streams?
Yeah.
Cool.
Yeah, one of the first things I did in Squeak, when Squeak itself started, was a communications framework called Flow, which let you create streams that looked pretty much the same no matter what transport was actually underneath. And WebSockets fit into that nicely.
better than Comet.
Oh yeah. Mhm.
Craig, could you talk through the bootstrap of this environment? So presumably at the bottom there's an index.html or something that says, I'd like to load some JavaScript, and that starts the ball rolling. But what are the steps?
Well, it sort of depends on what environment you've got, but yeah, at the core of it, let's see if I can share a different screen here. My Zoom interface, not sure where it is. Here it is. Stop this one. And now I'll share the dreaded Emacs. So here is the, can you see it?
Yep.
Yeah, so here's the index.html for this worldly page that we were looking at before. And yeah, it's basically just loading in a ton of scripts for all of these other frameworks I'm integrating with. They're mostly A-frame related. But they also include some A-frame components that I've written myself that do some things a little bit faster if you don't have to call out to them over the Squeak.js JavaScript bridge. So like there's a little animation that happens when you take one of these worldly cubes and rotate the faces so you can use a different one. That's being done as an A-frame component, for example. And then, yeah, some other little sneaky event handlers I've stuck in there for forwarding some events that can't be directly listened for otherwise in A-frame. Actually, A-frame is a really nice thing to integrate with because you can build A-frame apps just by going through the traditional web app workflow, writing HTML, JavaScript, and CSS, and that's it. It has an entity component system that lets you represent pretty much all of the objects you're going to be concerned with in the app as HTML, and send a lot of the messages that you're used to sending DOM objects to your A-frame entities. But somewhere in this A-frame scene, we've got a canvas, which is just a normal HTML5 canvas, onto which the Squeak.js VM will draw. And then A-frame has the ability to take at a high refresh rate the contents of any canvas or image and put it onto a plane in that 3D world. But then elsewhere in this whole thing is a script which actually starts the Squeak.js VM. And here, this is just a script called startup.js. And in addition to starting up a bunch of device driver-y type things, like making sure you have access to MIDI or the camera or the microphone, for example, it calls this function, start caffeine, and that's provided by the Squeak.js scripts. Yeah, if I can find it. Yeah, so eventually you'll get down to the Squeak.js run image function. So the web browser has already finished loading all of this, magic A-frame scene entity stuff. So now the only thing is to actually get the Squeak.js VM started and blitting to the canvas that you set up for it to blit to. Then you'll actually see it in the world. So that's pretty much the bootstrap process.
So where do I see the first sniff of Smalltalk? Well-known object perform a miracle.
Oh, well, I guess the first really magical object is the Squeak.js VM object, and you can tell it to start interpreting. Well, you can tell it to load up a snapshot, and then you can still tell it to start interpreting.
Okay, I guess that sort of segues into some of the questions that are popping up, because people have been asking about how do you manage the source code. So this, presumably at some point we say, I would like to reach out and grab some Smalltalk code and execute that.
Yeah, there are a bunch of ways you can do that. I mean, I originally implemented the system just to be used, interactively. So there's a human being actually typing into it and running it like you normally would as a native desktop app. But the Naiad system I mentioned earlier actually lets one running Smalltalk system imprint code onto another one and invoke it remotely. So that's one option. You can also have a Squeak.js system waiting on a semaphore, which can be signaled from JavaScript. And then once it is, it could look at some JavaScript object for source code to compile and run. That's another option.
So if you were like in a desktop Squeak and you want to just save some data, you'd open a file stream and write to a file. But in Squeak.js, it goes to the index DB. Right?
Yeah, which as far as Squeak is concerned is,
on Squeak side, it still looks like a file system, right?
Yeah.
So, and this is more of a browser question. Let's say you want to actually get it out of the browser, just as how would you get an index DB item out of the browser and into your computer, so to speak?
Oh, so in addition to starting the system, this Squeak.js part of the Squeak.js system can give you a different interface. Let me just start one up here. It can also present to you the IndexedDB file system as a web page. So I'm going to stop sharing Emacs.
If you go to the
share a different screen here. Do you see this other web page called Your Squeak.js Files?
No.
Hold on.
The Kiev
looks like the back of a postcard.
Yeah.
Share screen. Okay, here we go. How about now?
So the top left says Your Squeak.js Files.
Yeah. So this is another web page that you can view, and it's just showing the contents of this Squeak or this IndexedDB database that your web browser has cached, and it's showing all the files in that file system as links. And if you click on them, it will just download them.
Oh, okay.
And
that's the same. That's the same kind of thing. Like if I did save image as, that's the same area it would go to, right?
Yeah, exactly.
Okay.
And you can also drag and drop things into this dotted box here, and they will be visible from Squeak.js in the IndexedDB file system. Sorry, Vanessa, you were saying?
No, I was just going to point out that when you go to squeak.js.org and click on the launch page, that one has this kind of thing that lets you inspect the Squeak.js file space, the file system, and also drop files in. Like you can get files from your desktop, drag them in if you click launcher there.
As soon as I saw Craig's screen, I recognized it from playing around with Squeak.js. Yeah.
Exactly.
Yeah, so this page is a little more fully featured. It's, you know, it's the point of it is to demo Squeak.js. So it gives you a bunch of other links of other snapshots you can run, as well as the IndexedDB cache that it has for this squeak.js.org origin. Every origin gets its own IndexedDB.
Yeah, so about source code, yeah, you can just use change sets, like the old school file stuff works. At some point, also Monticello worked, like an HTTP GET request did work. I'm not sure if that's currently working or broken, but yeah, that used to work.
Yeah. And then this Naiad thing I'm building is sort of an alternative to Monticello.
Hello, question for Craig.
Yeah.
This is Peter. How much memory and how much, like if it wasn't using all the 3D stuff, just building a regular web app, a single page app or something that could eventually run on a smartphone, is Caffeine viable for building such web apps in a robust way?
I think it is, although the image size compared to a hyper optimized web app these days is gargantuan. I mean, like with the Svelte JS framework, people start to wince if the payload that has to go over the wire before the first paint is greater than like 15 kilobytes. And while I do have Squeak images that are 1 kilobyte in size, they don't have enough code in them to be, to do useful web apps. And yeah, so I mean, there are a lot of cheats you can do. You can offload a bunch of the behavior you would need for your web app, out of Smalltalk onto the JS that gets loaded along with the VM. But yeah, I think if you have a slightly more liberal view of what payload size you're willing to accept, then the possibilities go way up. And yeah, so I would think that if you were willing to accept a payload size of like 500K instead of 15, then you're in good shape.
So looking at Code Paradise, I think that runs on Squeak.js as well, and he's got a 200K image. But it's just a client-side thing. I don't think it has a compiler or anything else in it.
No, and that's the thing. For the apps that I'm doing, I like having this live coding ability, at all times, and ideally even module system support. So I would rather have a budget of 500K. Yeah.
If you go to the Squeak.js website, you can just try it on your phone. Like the mini image, which is I think 600K image, is very quick to load up. And if you sound like eToys or Scratch, that does work on your phone. You just go there and run it. It's on go back one page.
Oh.
Yeah.
This is not quite the mini image, but yeah.
No.
So for a regular web app, you wouldn't be using Morphic. You want some kind of HTML5 canvas. So it's a little quicker, better resolution. What's the best approach then if you wanted to write your app in Smalltalk and yet have it look like a normal web app or a normal app on the phone?
Yeah, so I've written apps where so what we're looking at now is an HTML5 canvas that Squeak is blitting to. And I've written web apps where, this canvas exists, but I'm not showing it. I would only show it if I wanted to actually do some hacking on the app using the Morphic UI. But you can instead use the or in addition, use the Squeak.js JavaScript bridge to send messages or invoke functions on DOM objects, and create a network of DOM objects just like any other web app would, and set up event handlers the way another web app would. But you're doing it in Caffeine, you're doing it having access to a Smalltalk class hierarchy, which mirrors the classes and objects involved in the DOM system. And I find that a lot more pleasant to do, because you can decorate those mirror hierarchies of classes with comments about what each method does, and you can add your own methods which provide aggregate behavior, because they can then turn around and make multiple calls on other lower level DOM functions.
Using something
so that's
like Vue.js or some other kind of framework.
Yeah. You could, these API calls you're making can either be to the built-in DOM objects using those low-level APIs, or to higher level frameworks like Vue. And I've done some integrations with Vue.js, and that's, Vue is my favorite of those frameworks. You could also do an integration with React, but I find the learning curve of React to be much steeper than Vue, so I chose Vue first.
Is there something ready to go somewhere with Vue pre-integrated, or from Smalltalk?
No, I haven't done that yet. That would be a good project.
Yeah. Thank you.
I just have one Vue app that I wanted to use myself, which is an app called Tabulator. It just keeps track of all the windows and tabs that you have running in your web browser, and lets you keep track of the tree of tabs and windows that you have ever had without having to keep them all open all the time. And so you can start and stop them at will and move them around in the tree. And yeah, third parties in the Vue community have written lots of nice, tree visualization things. So by integrating with Vue, I was able to reuse those. But no, I don't have like a general purpose starting point environment for writing Vue apps. That would be a nice thing to have. And that's a good. Sorry, that's a good segue to mention just that all of this stuff I'm showing is on GitHub. If you look for Caffeine and my name on GitHub, you'll find it. And in particular, there are several GitHub issue boards there. And this would be a good issue to open up. Sorry, you were saying?
Oh, so you're still looking at a budget of about 500K to have that kind of app running?
Yeah, not including Vue. So I don't know. Yeah. Being conservative, I would say maybe 700 altogether.
All right, thank you.
So to access the tabs that are outside of your origin or realm, you need to use like that debugging plugin, or what lets you break out of the browser security there, sandbox.
Yeah, exactly. To do stuff with tabs, yeah, you need access to all of the DevTools APIs. So you need to run this extension as well. And that extension, by the way, is in the Chrome Web Store. If you just look for Caffeine, you'll find it.
So there's no Smalltalk specific extension. It's a generic Chrome extension.
It's a Chrome extension that has Squeak.js inside it. So
oh, okay.
When you install it, then you're able to run a Squeak image in a Chrome DevTools panel.
Okay.
Yeah. And if it's running, you can talk to it from another Squeak.js running in any other tab in your web browser. Yeah.
I confess to doing a little bit of a double take when you were talking about a tree view, given the view I have in front of me right now, which appears to have trees behind it.
Oh, yeah. That's one nice thing about just doing normal work in this environment. So I'm always looking out the window. Even when I'm looking at my Squeak windows, it's translucent, so I still see trees behind it.
Craig, just to say thank you very much indeed. I've got to nip off because dinner is about to either go on the table or go in the dog. So there's the choice.
Sure.
I think I'll go
Yeah.
for it on the table.
Okay. Are there any more questions?
Thanks, everyone.
Okay, and then
Thank you.
thank you again, Craig, for your presentation. I'm gonna be stopping the recording now.